Okay. So before going to the next property, which is a convolution property, we will be first seeing a very important concept which will be required for your control system when we move on to some further detailed topic. It is known as the impulse response of an LTI system, which is a linear time invariant system. We have already studied linear and time invariant system as a separate topic in the class. Now we are going to see it as a combined topic, that is linear time invariant system. Now what do you mean by impulse response of an LTI system? So whenever we have a LTI system, there will be an input which will be also known as stimulus, and there will be a output which will also be known as a response. So when we give a input signal which is specifically a impulse signal. Now what do you mean by impulse signal? The impulse signal is the signal where at 0 you will be having a particular value, whereas there will be no value at negative side or even the positive side. So this is known as a impulse signal. Now what is the output? The output is the impulse response h of t. Okay, so this system, when we have a LTI system, and if we have a specifically a impulse input applied to it or a impulse signal applied to it, we'll get a response which will be called as a impulse response, which is denoted by h of t. Now what is the significance of a impulse responses? It is very important because it defines the characteristic of an LTI system. Okay, so what do you mean by impulse response? So the impulse response of a system is the response of the system when the input is an impulse signal, which I just told you about. Now how it is denoted by? It is denoted by h of t. Okay, which is mentioned over here. Now let's move on to the most important part of this particular thing. The impulse response is a characteristic of an LTI system. Like I said, the output of a system to any input is calculated by convolving the input with the impulse response of the system. Please note it very carefully over here. The output of a system to any input is calculated by convolving the input with the impulse response of the system. Okay, नाउ हाउ इट लुक्स लाइक, इसका ज़रा सा एक बार वापस से आएंगे थोड़ी देर के बाद यहाँ पे देखने के लिए कि क्या होता है. लेट्स मूव ऑन टू कॉन्वोल्यूशन प्रॉपर्टी. लाइक व्हाट डू यू मीन बाय दिस टर्म कॉन्वॉल्विंग? सो कॉन्वोल्यूशन प्रॉपर्टी स्टेट्स दैट एक्स ऑफ टी अगर है मेरे पास एज ए इनपुट एंड वाई ऑफ टी इज़ माई आउटपुट, so x of t will be represented as x of s and y of t will be represented as y of s. Okay, now if I have a x of t convolution with y of t, it will be written as x of s multiplication of y of s. So this is the most important property of convolution, that anything which is over here in time domain, that is the convolution in time domain, is getting converted into multiplication in frequency domain. So this is the most important property of a Laplace, is that convolution in the time domain is the multiplication in frequency domain. Convolution is very tough when we talk about, however multiplication is very easy. We will see this with one detail thing just in the next slide. Okay, so like I said, it is a system, LTI system, which is represented by h of t. Okay, this is the impulse response of a LTI system. Now if the input is x of t and output is y of t, what will be the final equation? So again we will come back to that particular statement. Yeah, so the impulse the output of a system which is y of t to any input which is x of t is calculated by convolving the input which is x of t with the impulse response which is h of t. So what does it means कि अगर आपको output निकालना है y of t, it will be equal to what? Convolution of input and the impulse response. So mathematically कैसा दिखेगा वो? So it will look like this. So in time domain, y of t will be equal to x of t convolution of एच ऑफ टी, जो हमने थोड़ी देर पहले अभी डेफिनेशन में देखा था. नाउ what happens over here? Now y of t is equal to minus infinity to infinity h of tau, अगर इसको स्प्लिट करेंगे, into x t minus tau d of tau. Okay, so it is very complex to solve y of t in the time domain. Now let's go to the frequency domain. What happens in frequency domain? X of t is equal to x of s, h of t is equal to h of s. नाउ वेरी सिंपल, y ऑफ s क्या हो जाएगा, कॉन्वोल्यूशन में इसका क्या होता है, निकल के यहाँ पे क्या आ जाता है, मल्टीप्लिकेशन. सो दिस इज़ द मोस्ट इम्पॉर्टेंट थिंग that when we talk about convolution in time domain, it is very difficult to solve. However, the convolution becomes a multiplication in frequency domain with the help of Laplace transform, and thus the simplification or the steps gets reduced, and thus with this we are done with the property of Laplace transform. Now we will be seeing in the next video maybe about the examples of inverse Laplace transform. Time being, this is what is the total concept of Laplace transform and the properties of Laplace transform. Thank you.